Hello everybody, my name is Iqbal Khan. Thank you for coming for this session. I'm going to go over this topic of how can you optimize ASP.NET Core performance, and I'm going to use distributed caching as the technique on making those improvements. And I'm going to use NCache as the example in this. NCache is an open source, so I'm just going to use the open source features. And if there are any tools that I'm using which are enterprise, you can ignore them. But all the features are open source. I prefer to keep the session more interactive. So if you have any questions, please feel free to just stop me so that we can just address that right there. We will also at the end try to have this Q&A, but I prefer to have it as we talk. Okay, I'm going to get started. Well, we all know that ASP.NET Core is the new, the .NET Core, the clean, the lightweight architecture, the cross-platform and open source. And that is becoming a major reason why more and more people are moving to ASP.NET Core. Also, there's a huge legacy ASP.NET user base, and especially if you are an ASP.NET MVC application, then moving to ASP.NET Core is pretty straightforward. If you're not an MVC, then of course you've got a lot of code read-write to do. So all of those are the reasons that I'm sure you're also here, because ASP.NET Core is the leading .NET choice for doing web applications. So when you have ASP.NET Core is being used more and more in high traffic situations. High traffic usually means that you have a customer facing application. You may be an online business, you may be a retail business. There are a host of industries: healthcare, e-government, social media, online betting, gambling, everything that you can think of. Everybody's online these days. A lot of those. So anybody, when there's a web application, ASP.NET Core is being used. That means ASP.NET Core needs to be scalable. What does that mean? Let me just define that. I'm sure you know a lot of it, but I'm just for completeness purposes, I'm just going to define the terminology. So scalability means that if you have an application that with 5 users, you got really good response time. You click it, and within a second or two, then the page comes back. Then if you can achieve the same response time with 5,000 or 50,000 or 500,000 users, then your application is scalable. If you cannot, then you're not scalable. If you don't have a high performance with 5 users, then you got to go to some other discussions about how you've written your code. But I'm assuming that your application is developed with good algorithms, with good approach, and it is a high performance application with 5 users. So how do you make it high performance under peak loads? So if you can go from 5 to 5,000 to 50,000, that is called linear scalability. And the way you achieve it, as you know, in a load balanced environment, you deploy ASP.NET Core application with a load balancer, and you add more and more servers. So as you add more servers here, your transaction capacity, your number of requests per second capacity increases in a linear fashion. If you can achieve that, then you will be able to achieve that same performance. And that is the goal of today's talk, is we want to be able to achieve this high performance under peak loads. So if you don't have a high performance under peak loads, if you don't have a linear application, that means that you have some bottleneck somewhere. So as soon as you add load beyond a certain threshold, then it doesn't matter if you add more boxes. Actually, it's going to probably slow things down because there's a bottleneck somewhere that is preventing your application. So you definitely don't want to be a non-linear scalability. Just to recap, what types of applications need to be scalable? Obviously, ASP.NET Core, which is what we're talking about. You might also have web services. That means ASP.NET apps are the web apps. That means their users are humans. Web services are, again, web apps. Their users are other apps. Microservices is a new, relatively new concept that is also for server-side applications. Of course, that involves re-architecting your entire application. I'm not going to go into how you do that. I'm just mentioning the types of applications so that you can map whether whatever you guys are doing or your company is doing would map into this or not. And finally, a lot of just general server applications. These server applications may be doing batch processing. For example, if you're a large corporation, let's say if you're a bank, you may need to process a lot of things in the background in a batch mode, in a workflow mode, and those are the server apps. So all of these different types of applications need to be able to handle scalability. That means they need to be able to process all those increasing transaction loads without slowing down. So, there is obviously a scalability problem, or else we wouldn't be having this conversation if everything was fine. The good news is that your application tier is not the problem. Your ASP.NET Core application is not the problem. It's the data storage. Whatever data you're touching, whatever, it doesn't matter what that is causing a performance bottleneck. And that is your relational databases, your mainframe legacy data, and a bunch of other data. Interestingly, NoSQL databases are not always the answer, because in a lot of situations, you're not able to, because a NoSQL database asks you to abandon your relational database and move to a NoSQL database or a NoSQL database, which you're not able to do for a variety of technical and non-technical reasons. And if you're not able to move to a NoSQL database, what good is it, right? So my focus is that you have to solve this problem with relational database in the picture, because that's the database that you're going to have to use for, as I said, a variety of reasons. And if you're not able to move away from it, then NoSQL databases are not the answer in many situations. So you should continue to use a relational database and instead deploy a distributed cache in your application. Here's what it looks like. So if you see, you've got the same application tier. You can add more and more servers to it as your transaction load grows. In case of many of these, let's say web apps and web services, there's usually a load balancer up above, which is making sure that every web server is getting equal load from the users. In case of server applications, it may not have a load balancer. It may. It depends on what the nature of the application is. But the fact is you can add more and more servers, and there's only one database here. And I said there may be some NoSQL database for some smaller specialty data, but majority of the data is still relational. So the goal is to put a caching tier in between, and a distributed cache is essentially a cluster of 2 or more servers. And these servers are low-cost servers. These are not high-end database type of servers. And everything is stored in memory. Why in memory? Because memory is just so much faster than hard disk. If your application needs to perform more and more, you need to be absolutely clear about this. Hard disk, whether it's SSD or it's HDD, is going to kill you. You have to go to in-memory. Everything has to be stored in memory, or else you're not going to achieve the performance that you want. And that is regardless of whether you go to a distributed cache or not, but in-memory is the storage. So a distributed cache has two or more servers. It forms a cluster. And the word cluster means that every server knows about the other server in the cluster. They pool the resources, the memory, the CPU, and the network card. So those are the 3 resources that it pools together into one logical capacity. Memory, because every server has RAM. So a typical configuration that we have seen our customers use is between 16 to 32 gig of RAM in every one web server, in every one cache server. Minimum of 16, we recommend between 16 to 32. And then instead of going above 32 to, let's say, 64 or 128 gig of RAM in each box, which then requires you to increase the CPU capacity, because the more memory you have, the more garbage collection you have to do, because .NET uses GC. So the more garbage collection means more CPU, or else garbage collector becomes the bottleneck. So it's better to have 16 to 32 range and not bigger, and just have more boxes than to have 128 gig of 2 boxes. So that's memories first. CPU obviously is the second thing. Again, typical configuration is about 8-core box. Some of the higher end deployments would use about 16 cores, but 8 core is good enough per box. As I said, low cost servers. And the network card, of course, because whatever data is being sent from here to here is being sent through the network cards. Now, on the application tier, you have obviously more application servers than the cache servers. And again, usually what we recommend is about a 4-to-1, 5-to-1 ratio. 5 application servers to 1 cache server with a minimum of 2 cache servers. So if you have 5 application servers here, they have 5 network cards. They're sending data to 5-to-1 ratio of network cards. So the network card, you got to have at least 1 gigabit or 10 gigabit network cards in the cache servers. Other than that, you just need to pool them together. And let's say you start with 2 as the minimum. And when you maxed out 2, what's going to happen is you'll start with 2. You'll run your application. Everything is going to run really super fast. Or maybe you're doing load testing. Everything's going to run super fast. And you increase load. Suddenly, the server side will start to see higher CPU, higher memory consumption, and the response time is going to start to slow down. Now that's what's going to happen with a relational database, except here you can add a third box, and suddenly you get another big relief, and now you start with, again, higher throughput, and now you can add more and more transactions. It's going to start to peak out, and then you add a fourth box, So that's how this picture continues to increase, and this never becomes a bottleneck. They say never, but in almost never it becomes a bottleneck, because you can add more and more servers, and as you add more servers here, you just add more in this caching tier, which you cannot do with the database. Now, I put 80-20 load. In reality, it's more like 90% traffic goes to the cache, 10% goes to the database, because more and more data you're going to just read from the cache. I'll go over some other aspects of it that a cache has to handle, but this is basically a picture. This is the reason why you need a distributed cache. Any questions on this so far?
You're making an assumption that 9 out of 10 requests are going to be reads, is that right? Under that, you're saying 90% of the load, right?
Yeah, actually, majority of the application data, and again, there are different types of data, and I'll go into that. There's some data which are what we call transactional data, which is updated much more frequently, and there's some data which is transient data, which you're keeping in the database traditionally because there was no other place to keep them. So you move all the transient data out of the database. You keep it in the cache, so it doesn't even reside in the database. A good example is sessions. If you have a web application, ASP.NET Core sessions, if you were to keep them in the database, for every web request, there's 1 read and 1 write. So equal number of reads and writes. So that 9-to-1 ratio is gone. It's 50-50. But then you shouldn't even keep the sessions in the database, because only permanent data should stay in the database. When you're talking about application data, majority of the time you will read something, you'll update once, and you'll read it multiple times. Within the same user session, you'll fetch that data multiple times. And 80% to 90% is pretty much the average. And we've seen this, and we've been doing this for more than 10 years now. It's pretty consistent across the board. Application data, when you try to cache everything, and you have to do all the best practices, of course, but when you cache everything, you don't touch the database more than 20% of the time. But then you have to move some of the data out of the database and not keep it in the database at all. So actually, what you should be doing is adopting this as a best practice in all application architectures. So if you're developing any ASP.NET Core application, just assume that you got to have cache in it. If you don't have the cache, now you will have to add it at a stage, at a later stage with a much higher cost to your business, because you will have gone through some painful experiences because the peculiar thing about caching is it's like a vitamin. But when you're doing heavy lifting, when you've got customers coming in, your business is doing, it's an online business, right? You're a bank, you're doing a lot of online banking, so a lot of customers are coming in, you're an e-commerce store, whatever. So when are you going to have problems? When you have the largest number of customers. And what happens when the database does become a bottleneck? It starts to slow down. What does a slowdown do? If your customers are not very loyal to you, if they have alternatives, as soon as your response time drops below or increases, if the page takes longer than a certain time, let's say if your page is taking 3 to 5 seconds, it's considered good. If it's taking 15 seconds, it's painful, but people probably tolerate you. But if it's taking 30 seconds, trust me, you're going to lose customers. People will just move away to your competitor. And there have been documented studies so that the actual drop in performance is directly proportional to effect on revenue for online businesses. So you will find that you're losing a lot of revenue. And then let's say we've got some high transaction customers. Let's say that you're an airline and you just did a special holiday promotion to Hawaii or to Florida, from the Midwest or someplace. And suddenly everybody and their uncle is on your website trying to search for flights and buy tickets. And you have a database, so it starts to slow down, and it crashes. And that crash was there for at least half an hour to an hour is about what it's going to take, the minimum time for you to recover. An hour of downtime at that time, imagine, is worth probably hundreds of thousands of dollars. So the cost to your business is really high when you think about it from a management perspective. But from a technical perspective, it will occur because you didn't architect things correctly. If you had architected this thing correctly, all you have to do is add another box. Now your application tier allows you to add boxes. That's what ASP.NET Core does, or ASP.NET did, but your database does not. So those are the things that you got to make sure that you put a caching tier in between. Even if you don't need it now, if you put it now, many of these caches are open source. NCache, as I said, the example that I'm using is all open source, so they're free. So if your application is at a stage where it's really not that mission critical, use an open source free cache. As the application becomes more and more important, move to or upgrade to a enterprise or supported product so that you guys can do it. But make sure you have a distributed cache as part of your architectural plans. Any questions before I move on?
So to a certain point, if I have, say, an app in Azure and I'm using, the Azure SQL Server,
right,
I can just crank that guy up because they have the metal up there to just give me more and more DTUs, right? To a point. But how does that compare to paying for those?
Anybody who's telling you that you can scale SQL linearly.
Well, to a point.
As I said, maybe you can go from 1 to 2 boxes, but even there, you're doing more for active load balancer, active passive. There is no distribution that is done automatically for you. The nature of relational databases is that you just cannot distribute. The reason you're able to distribute in NoSQL database and also in a distributed cache, because everything is key value. So all the keys are independent entities. That is not the case in relational databases. You've got table, you've got multiple columns, you've got blobs in the columns, you've got relationships, you need to do joins, all of that stuff. There's no way that you can distribute. So that's more of a marketing buzzword saying that you can scale. In reality, you're still dealing with a relational database like you did in the past. They're just managing it for you. And if you want to scale, you have to put in a distributed cache. That's for the scalability. The other part is the performance for in-memory. A distributed cache, as I'll go through the more details of this, there's no way a relational database can match the speed of an in-memory cache that is very close to your application. So I would strongly recommend, as I said, if you don't plan it ahead of time, then the cost to your business is very high. And then it makes you guys look bad that you didn't do all the proper planning. Maybe you didn't do your homework. You didn't come to my talk, you know. But I think, you know, it's pretty much understood now, because thing is, the technology has changed so much that the transactional loads on applications are tremendous. I mean, if you have 100,000 concurrent users, that's a lot of users. That was never the case prior to the web and all of the others. So, I mean, you've got to plan appropriately. Okay, so let's move on. Now that hopefully I've convinced you that you need to incorporate a distributed cache in your application, the first question that comes to mind is, well, what do I do with it? How do I use it? So there are three main categories in which you can use a distributed cache. There are others, but for most of the discussion here, there are three really high level. Number one is application data caching. This is what I've been talking about up until now. Whatever data is in the database, that's what I'm calling application data. You're caching it so that you don't go to the database. Now, keep in mind, and with each of these, with an application data caching, the nature of the problem is that the data exists in two places, the cache and the database. And whenever data exists in two places, what could go wrong?
Sequencing?
Yeah. So the data could get out of sync. So if your data in the cache was out of sync from the database, that could create a lot of problems. I could withdraw $1 million twice, assuming I had to begin with, but let's say that. That's the first problem that comes to mind. So any cache, any distributed cache that is not able to handle that problem means that you're limited to read-only data, what we call reference data. And read-only data, and that's how caching began as to be understood. You know, cache read-only data. You know, my lookup tables. The lookup tables is about 10% of your data. In some applications it's not, but an average application, 90% of your data is not lookup data. It's transactional data. It's your customers, your activities, your orders, everything. So if you're not able to cache all of those, then the benefit, let's say 10% of the data, maybe the lookup is really being done more than its fair share. So that 10% could give you the benefit of 30%. But you still have 70% of the data that you have to go to the database. So but if you could cache all data, which you would only be able to if you get that comfort, then you will get the real benefit. The second use case, or the second way of using, is what I call ASP.NET Core specific caching. And there are three ways of. One is the sessions, which is the most commonly understood. ASP.NET had them, ASP.NET Core has them. They're here to stay. I don't think sessions are going to go away, even though some people argue that we should not use sessions. There's no harm if you use them. The only problem with them is that where do you store them? That was always the problem with ASP.NET. Whatever storage options Microsoft gave you were all full of problems. So the only option at that time was to use a distributed cache, which you could fortunately plug in as a custom option in the ASP.NET days. In ASP.NET Core, Microsoft, does not have a built-in well, they do have like a standalone in-memory, but they straight away go into an distributed cache or custom session provider, which you can plug in through a third-party distributed cache like NCache. Sessions is the first. The second is response caching. I was going to say, who doesn't know about response caching, but that's not a good way to ask. Response caching is like a newer version of output cache, but it's more standards based. It's the page output that you can cache, and I'll go over it. But that's also something that you can cache and plug in a distributed cache as a middleware for it. And a third is if you have a SignalR application, which is the live web app. Live web apps are those where, let's say, if you have a stock trading application that needs to constantly, propagate all the stock price changes, and it's got hundreds of thousands, maybe, clients. They're all connected, so they'll all stay connected to the caching or the application tiers. And the application tier, it's unlike the regular HTTP, where for every web request a new socket connection is opened. Here, the socket connection stays open, and events are propagated from the server. So in a SignalR, when you have a higher transaction, large number of users, you got to have a load balanced web farm. But since the sockets are kept open, so every server is going to talk to its own client. But now all the clients or all the servers have different sets of clients, so they need to share data. So that data is shared through a backplane, and that backplane becomes so that's where you plug in a distributed cache. I'm not going to go over the details of that specific. I'll go over the first two, but not the third one. Now, the specific thing about ASP.NET Core specific caching is that the data exists only in the cache. This is where I was saying, don't put it in the database. There's no need. This is temporary data. You only need it for 20 minutes, 30 minutes, hour, 2 hours, whatever. After that, the data needs to go away. So if it's temporary, then it should only exist in the cache. And when the data only exists in the cache and it's an in-memory cache, what could go wrong?
Is power thing?
You could lose data, because it's all in memory. Memory is volatile. So a good distributed cache has to handle that situation. Of course, that means you need to replicate. The third use case is a lot of applications need to do workflow type of operations. Microservices is a very good example of it. They need to coordinate activities, although microservices is not the topic, but even ASP.NET Core applications occasionally need to do that. So pub/sub messaging is another way, because you have, again, keep in mind, you have an infrastructure in place where all of these boxes are connected to this redundant in-memory infrastructure. So why not use it for pub/sub messaging also? So those are the three common use cases. Any questions on this before I go into the details of these? So these are the three ways that you should use NCache or a distributed cache if you want to benefit, if you want to maximize the benefit. So I'm going to quickly, before I go into how you actually use them, I want to actually show you what a distributed cache looks like, just so that you know. I'm going to use Azure as the example, or as the environment, and I'm going to use NCache, and it's just a quick demo of. So I'm logged into Azure. I've got I've got 4 VMs. Again, these are all .NET Core.
That's a question.
Yeah, go ahead.
So you can use the cache as a queue?
You can use a yes, you can use a cache as a queue. You can also, there are also some other features, like you can have data structures in the cache, lists, queues, stacks.
Okay, I just wasn't aware that there was a queue data structure.
Yes, exactly. There is, and because again, when you have a common infrastructure in memory, for example, one of the use cases maybe you want to have a common, like a unique counter, like a unique ID, which databases usually give you. But if you wanted to have it outside of the database, a cache is a good place to do it. So I've got 4 VMs in Azure. Two of these are I'm going to use as my cache server VMs, which is basically, these are those two. I'm going to have one Windows client and one Linux client. So if you have, because .NET Core supports Linux, if you have .NET Core as the application, you may want to deploy this on Linux. Now, in case of NCache, and again, I'm not marketing NCache here, but in case of NCache is .NET Core, so it can run on either Windows or Linux, both the servers and the clients. Okay, let's go into. So I'm logged into the client, the Windows client box. So I'm going to now go ahead and create a cache for myself. So I'm going to use this tool called NCache. The NCache manager actually does not come with open source. There's a command line equivalent of it, but I'm being lazy here, so I'm just going to use NCache manager. But it's the same functionality. The functionality doesn't change. So I just launched NCache manager. I'm going to say create a new cache. You just name a cache. All the caches are named. It's a name. Think of that as a connection string to the database. Then you pick a topology. I'm not going to go into the topologies yet. I'll go into toward the end about what a cache needs to do to be able to handle all those needs. So I'm just going to use partition replica cache topology, asynchronous replication. I will add my first cache server to 10.0.0.4. I'll add the second one, 5. So I've got 2 cache servers. I'm going to keep all other as defaults. I'm going to evictions and all the others. And I'm going to now specify 2 clients. Oops. 5. Nope. 6. Sorry. 6 and 7. So I have basically, and I'm going to come here and I'll just say start the cache. So think of it just like a database. You instead of one server, you got multiple servers that constitute the cluster, and you create a cluster of cache servers, and then you assign clients. You don't have to assign the clients because you can just run them, but I'm doing it here because it gives you some more flexibility. Then I want to go and test the client. So I am the client. So I think I'm .6. Let me just make sure which one am I. I think I'm .6, I think. Come on. So again, I'm doing everything within the Azure Virtual Network. So all the client, the client actually is the application server, and the cache are all together. Now you could also, in case of NCache, you could have gotten this from the Azure Marketplace. So .6 is the Windows client. So I'm going to launch PowerShell. And I'm going to make sure that I can see. Okay. Okay. So you'll see that this client is going to talk to the cache, and now I'm doing about 500-600 requests per second on each of the cache server. Let me add some more load. I'm going to open another PowerShell, and I'll do stress another instance of the client. Now you'll see that it'll go up to about more than 1,000 to 1,300 per server. And now let's do this. I'm gonna actually, so I've opened up a command prompt here. Let me log into the Linux box. Just gonna. So, oops. And sorry. Let me start PowerShell there. I need to import the PowerShell libraries of NCache. And I will do the same stress demo cache. So I'm gonna, before I do this, as you can see, I'm doing about 13 to 1500 per server. Let me add this as a Linux-based client talking to the cache, and now suddenly I have almost 2,500 requests per server. So I'm doing about 5,000 requests per second on 2 servers. So as I said, you can add more and more load. And as you max out those 2 boxes, which you will, then you add a 3rd one. Then you add a 4th one. So that it's as simple as that. And again, this is a simulation. It's an actual. This is like a stress test tool. So this is what you have to keep in mind. I'm going to continue with the actual cache now. Hold on, let me just.
What tool are you using for stress test?
It's a stress test program. It just puts in like a byte array. I think it puts in 1K of data. It does add, it does update, it does get. So it simulates whatever your it simulates your actual application, and it has parameters that you can change to see what is the ratio of reads versus writes, as we were talking about. And this is a tool that we give with NCache, so that you can actually test it in your own environment. So to see how NCache is actually performing before you actually spend a lot of time migrating your application to it. Let me just quickly go through. I think I'm running out of. So now that we've seen what a cache looks like, how you can add more clients and how you can add more load on it. It's very simple. So the easiest way to use a cache is to put sessions in it. And for sessions, there are 2 things that you can do. Either you can just use an iDistributed cache provider. Let's say NCache has one. And as soon as you specify NCache as an iDistributed cache, ASP.NET Core starts to use it for storage of sessions. So let me actually show you. So I've got this ASP.NET Core application, as you can see here, and in my configure services, I'm specifying this. I'm saying make NCache my distributed cache provider. So as soon as I do this, it starts to, and then I'm using standard sessions, and these standard sessions will use iDistributed cache, which is now using NCache. So whatever distributed cache provider you have, that's all you have to do. Based on this, so as you can see, very small code change, and your entire application is automatically, all the sessions will immediately be put into a distributed cache. And one of the things that we've seen is when many of our customers, when they're storing sessions in the database and they're having issues, for them to plug in something like NCache is instantaneous. And the benefit that they see, remarkable improvement, is instantaneous. Because for the least amount of effort, the maximum gain is there. Because, of course, the application data caching is there too. I'm going to skip a few because I think, so there are multiple ways that you can specify sessions. One was the iDistributed cache. The second is that you can actually use a custom session provider, which NCache also has. And again, all of these are open source. Then for response caching, again, you do the same thing. You specify NCache as the distributed cache, and it automatically becomes the cache for the response caching. I'm not going to go into more detail. Now, I wanted to touch base on this topic a little bit more. So when you do application data caching, unlike sessions, you actually have to now do API programming, unless you're doing entity framework core. So for example, in case of NCache, again, open source, there's an EF core provider. So we've implemented extension methods for EF core. So you can actually plug in NCache, open source, and use your regular EF core queries, and at the end you can say from cache or from database, something, just an extension method that automatically starts to cache stuff. It gives you total control over what you want to cache, what you don't want to cache. Do take a look at it. It's a really powerful way. If you are doing EF core, which is what I recommend that you do, I think for any .NET Core, any ASP.NET Core application, all the database programming should be done through EF core, especially since EF core is a much nicer architecture than the old EF. So that's one way to do it. The other is that you can actually you can use the distributed cache API or the interface, which gives you flexibility to not be locked into one caching solution, but it comes at a cost. It's very, very basic. There's only a get and put, and that's basically, well, there's a remove also. That's about it, And all the things that we talked about, if you can't keep the cache synchronized with the database, all of those things, you lose all of that. So if you want to benefit from all those features, then you've got to go into the API that actually supports all of those. And again, because you're going to be committing to an open source cache, it's usually easier to do that. But the application data caching, the API is very straightforward. There's a key and there's a value. The value is your object. Now, let me come to that topic of what allows you to keep the cache fresh, the really valuable information, right? What do you do? Well, the first thing almost every distributed cache does, expirations. You do absolute expiration. Whatever you put in the cache, you say, remove it from the cache 5 minutes from now. So it's safe to keep in 5 minutes. I think in 5 minutes, I'm the only one updating it. After that, other people might. So that NCache has it. Everybody else also has it. Transient, there's a sliding expiration for transient data like sessions and others, that after you're done using it, if it's not touched for a certain amount of time, let's say sessions, when the user logs out, after 20 minutes of inactivity, the session expires. So the same thing happens. Expirations, pretty much everybody has them. Next is the synchronized cache with the database. This is a feature that allows you to have the cache monitor your database. So you can actually, when you're adding stuff to NCache, let's say, you can have a SQL dependency, which allows NCache to monitor, and a SQL dependency it's a SQL Server ADO.NET feature that we use. SQL dependency allows you to specify SQL statement or stored procedure that allows NCache to monitor your SQL Server database, that specific data set. And if any changes happen in that data set, SQL Server notifies NCache, and NCache removes that data from the cache. Or if you combine that synchronization with a read-through feature, then it reloads it. So let's say you had a customer object that was cached, and it was SQL dependency, and that customer got changed in the database, which is customer is a transactional data, so it's going to change frequently. You can use read-through and automatically reload upon either expiration or database synchronization. So now suddenly your cache is responsible for monitoring the data. There are 3 ways that you can do that. There's SQL dependency, DB dependency, and CLR stored procedures. I'm not going to go into the detail of it. You can go to our website and read it. But again, most important thing is if you don't have synchronization of cache with the database as a feature, then you're limited to that read-only and static data. And then that limits the whole thing. And again, you can synchronize this cache with a non-relational data source also. The third thing is that you may have a relational, most of the time you are going to be caching relational data, which has one-to-many, one-to-one relationships. So when let's say one customer has multiple orders, if you remove the customer, the orders should also not stay in the cache because maybe you've deleted it from the database. So if you don't do that, then your application has to do all of this. But there's ASP.NET Cache object has this feature called key dependency feature. NCache has implemented it that allows you to have a one-to-many or one-to-one relationship between multiple cached items, and that if one thing gets updated or removed, the other thing is automatically removed. So those 4 things combined allow you to make sure that your cache stays fresh and consistent with the database. And this is what allows you to then start to cache data. So that's the first real benefit. The second is that if you can use read-through and write-through, it simplifies your application. Read-through, as I said, you can combine read-through for auto reload, which is something that your application would not be able to do if you didn't have read-through. And write-through, again, you can update the cache, and cache can update the database. Especially if you have a write behind, then again, we're talking performance, right? So all of the updates have to be made to the database. Well, and the updates are going to be slow compared to the reads from the cache. So what if you could delegate the updates to the cache and say, I'm going to update the cache, why don't you go and update the database for me? I know it's safe because we're going to work on the eventual consistency model, which is what distributed systems are all about. That you sacrifice or you become more lenient on consistency, and you go with eventual consistency model, which means that even though at this point in time it's not consistent because the cache is updated, the database isn't, but within a few milliseconds it's going to get updated. And some data you cannot afford to do that, but a lot of data you can. So by doing write behind, suddenly your updates are also super fast. Your application does not have to incur the cost of updating the database. The cache does, which is a distributed cache, and it can absorb that as a batch. And there are other, so once you start to do this, that means now you can cache a lot of data. Once you cache data, more and more data, then your cache becomes as rich almost as a database. That means you're caching almost all the data. When you cache almost all the data, then key value is not enough to find things. You got to be able to search things. So like App Fabric used to have groups and subgroups, tags, name tags. By the way, NCache open source has an App Fabric wrapper. So for those of you who got App Fabric can move to NCache as a free thing. So grouping allows you to fetch data easily. SQL searching allows you to find things like, give me all my customers where the city is New York. So now you're doing database type of queries in the cache. Why? Because your cache is now containing a lot of data. The whole paradigm is shifting because you're going with more and more in memory. Again, the database is the master. So the cache still only has it for a temporary period of time.
Can we go ahead and break the ball and do
Yeah.
a Q&A?
Yes. I think that my talk goes further, but I'm gonna end here because I think we don't have time. Any questions, guys?
Are there any tools or coding standards that you'd recommend to help you keep track of? Because when you program with the cache, if I do a write, I have to think about every place that's reading that same data in the cache, right?
No, actually, the cache will take care of it. So the cache has to be coherent. When you write something from one side, it has to be immediately available to everybody. Okay. If it's not, then it's inconsistent.
It will take care of that for you?
Yeah, exactly. Thank you very much. Thank you.